Well, good afternoon. Wanted to show you a new auction score that I got. $65. This is a Fluke 5440B DC Calibrator. Now, if you've been following some of my posts, you probably would have seen on the EV blog, you would have seen that I've actually already bought one of these. I have a 5440B/AF, and the AF is the Air Force model. This one is also being used by the Air Force, but was not the special AF model that the Air Force had made. So it's the full 5440B. The reason I bought this is that I took my 5440B and dropped it off to Fluke calibration to have them give it a solid calibration, because that unit being calibrated along with my Hewlett-Packard 3458A being calibrated enables me then to calibrate my Fluke 5200A AC calibrator, and that gives me a set of AC and DC calibration standards that I can utilize here in my home lab. And so I wanted to get a known starting point, and I sent my 5440BAF off to Fluke, and they noticed that it had a little bit of problems with it, and so they've been letting it run for a while. It seems to have come good, but there was an issue with the relays on the 1000 volt or the 1100 volt range, and so they were thinking, well, they may have to replace the relays. And I thought, well, you know, if they replace the relays, then God knows how much that would cost. I sent away a unit to be repaired by Keysight, and I got an $8,000 bill back. So I happened to notice this come up on government liquidations, and so I thought, well, hell, it doesn't power up. I'll bid on it, and at least then I might be able to get some working relays. So the unit just arrived today, and I wanted to give you a quick look at it. Interestingly enough, my unit, when I got it from the government liquidation people, it was missing its fuse holder. So is this unit. So I wonder if there's a common problem with the fuse holders coming loose and falling out, or if they're just really a rare component in the Air Force, and so they keep stealing them from units that they're trashing. Anyway, I thought I'd give you a little bit of a look of this unit, even though I can't turn it on. I have to get a replacement fuse holder. The unit is a 7.5 digit capable unit, and so what you can set up here is a set of DC values that you can utilize to calibrate any multimeter up to 7.5 digits. And these units are actually pretty cool, because what they have is they have an ability for you, and this is where you would see it over here. They have an ability for you to actually control have the calibrator tell you what the error percentage, or the parts per million error, is on the device that you're calibrating. So what I can do is I can actually put in all of the ranges and say that here are the ppm values that I should have as range plus digits and so on into the actual calibrator, and then I can connect my meter that I want to calibrate straight up to this, and my alarm system has just gone off. And then what I can do is I can use these controls here to go in and bring the display back to the value that I've actually set. Once I've done that, I will be able to see an error value appear up in the secondary display up here, and that way I can see whether or not there's a pass-fail. Now, the difference between, or at least one of the major differences that you'll see on the front between this and the AF unit, is this little tray down here. And if I pull this little tray out here and we have a look at it, this is a little procedure storage module. And basically it's just a flat board in there, and you can see that it's got some probably EEPROMs in there. But basically what that lets you do is go in and create take your procedure that you would check, and such as, you would set the voltage to this, and then you would check that, and then you would check this, and you can enter all that into the device, and then store that procedure onto that memory module, and then come back to it to pull that back in and load it back into the system, and then go through that automated procedure. So on the front panel here, we have the fairly standard set of binding posts. You'll have an output, a sense, then you'll have a guard and a ground, and a little bar here that lets you decide whether you want the guard to be connected to the device ground here, or whether you want it to be connected to the guard terminal that will happen on the unit under test. And then you have a divider output. Now the divider output, I'm told, and I haven't been able to verify this yet, but I'm told that the actual values of the divider, it's designed so that you can get extra resolution as you go down very much into the low values, so you're below 1 volt, and get additional resolution in there. And I'm told that these things aren't particularly accurate. The Fluke manual says that they are particularly accurate, but I'll believe the good people that have been using them that this is the case. So this is the basic look at the front of the unit. Let's switch camera angles and take a quick look inside. Okay, so here we are with the top off. The unit's so big that from where my camera's mounted, you can't really see where see the whole thing. But before we go any further, I thought I'd just show you what is basically here on the unit. Up here in this corner, this is where the power supply is. It's basically going to give you the rails that will run the digital signals here, and let you run the control system, which is, let me move this back in, is up in this area over here. And then these are the set of boards that are in here that will do most of the that do all of the voltage control and so on. This control unit is basically the memory controller, the controller for the outside regulator for the items at the back, and so on. And then all of the main components are basically in here. The voltage high voltage PCB, the sample string, the preamp, the DACs, the reference, and all that all live in here. Now these have these cool little pins on them, and you can see they're like sort of clothes pegs. If you're old enough to remember the old wooden clothes pegs from the backyard, and they basically go over the top of the board, and they just help hold that board in place. So to get a look inside underneath this, we're going to have to take these panels off. So we'll take each of these little items out and then have a look further in. Okay, here we are. Again, this unit is so big that I can't get it all in shot with my normal desk cam mount. So we'll try and move it around and have a look at what's here. So the first thing that I'm going to do is just start at the back of the unit, which is over here. And what I have is this handy little diagram that you guys will be able to look at, and this is how it's oriented here. But we basically start with a section of these control boards, and they're actually really well designed, because to get them out, all I need to do is just lift the two little catches there, and the boards will pull out by themselves. And they're fantastically, well built, well thought out boards for the era. And so what we can see here, this is the memory board, and so this will be A15, I think. Is A15 written on it anywhere? Oh, it's memory board, but yeah, I don't see A15 on it. But these are all going to be discrete. They're all going to be through-hole components. There's not going to be any There's not going to be any surface mount stuff here as far as I'm aware. Now, what these units are is they're great for servicing because they have a lot of enunciators here that will tell you information about what is going on in the unit. So my previous 5440 that I got, when it would boot up, it would go through and you would see these lights here go and cycle properly, and then this light would come on. And so what that would be telling me is that, and in fact, let's take that board out so you can look at it, and that's going to be the controller, the A16 controller assembly. Let's see if it's marked controller assembly. Yes, it is, controller assembly. And so what you can see if I zoom in, let's just zoom in a bit, what you can see on these boards here, the enunciators are going to go through CPU, memory, I don't know what I can't remember what internal and FPC stand for, but basically they cycle through very quickly, testing all of the individual parts of the system, and then that will tell you what is going wrong here. And so if I take this board out, you know, this board is, let me move this one out of the road, ouch. This board here is going to be your actually I don't know, this is the it's not A18, this is going to be, oh sorry, A17, this is the outside guard regulator board. What you'll see is for circuits that are outside of the guarded area, this will provide the power regulator. And so what CR12 here does is if you have a fault here, and I should put this, I'm horrible with the camera once I'm zoomed in, I forget it all the time. What this board here is, CR12 will actually go through and if there is problems with any of the rails, and you can see they've got great sets of test points all across the top here that enable you to test the various different rails that are in the system. You'll see that this red light will come on and tell you that basically to protect itself it has shut down power. So that gives you a great way of just simply getting a handle on where the problem is with the unit. So let's zoom back out again. So what you would do, let me put these boards back in. I'm waiting for the, as I said, I was waiting for the fuse holder to arrive. So at that point, I'll actually be able to power the unit on. But what I saw in my previous one is the unit, if there's no problem with the power supply, what should happen is the unit should start going through the cycling of these LEDs here, and then that CR12 should never light up. But if you actually get a problem with one of these other boards, then what's going to happen is it will light up and you'll see these will all be stopped. So if that process works, then I know that the microprocessor part of controlling the system works fine. And if this light comes on, I know then it's a power problem. And in fact, the problem that I had previously was with the display, and there was a shorted capacitor on the display panel, and that was causing the outside guard regulator to detect the oversupply issue and then turn itself off to protect itself. So what we go through, and if I bring in this this again, these are the items that are in the guard area here, and so basically all of this stuff here is utilized to provide the control and management of the actual systems. And so we'll take the boards out and have a look at some of them. And then these boards over the back here are where you're going to generate your actual high voltages that are going to be controlled by the boards over here. So if we take a little look, and let me flip over the page here, you can see basically, and let me zoom in, you can see basically what the block diagram is. I'm going to come in and set some voltage, and that voltage is going to control what is actually done in the output stages. And so the system here uses a 13 volt reference. There's been a great thread on the EEV blog, and if I remember, I'll link it in below, that talks about whether these are artifact calibrated or not. And somebody's been doing a 10 volt calibration against the 13 volt reference internally, and found out that yes, these are, or at least they appear to be, artifact calibratable. So basically what goes through is you set your value here, and then you get an analog value is sent out into the preamp over here, and then the feedback loop goes through the output control set, the output PC assembly, the PCB assembly, goes through the feedback, through the sample string, back into the preamp, and gets controlled. And then it's finally put out on the output of the device here. So if we have a little bit of a closer look at this, you can see what I was talking about in terms of the guarded, non-guarded part. The digital part of the controller here is basically not guarded, because it's outside of the area that you're trying to keep very tight control of in terms of the interference and so on. And so all of this control circuitry that you have up here, the microprocessor, the front panel, the DAC assembly for I/O, for HPIB and RS-232 and so on, all go through an opto-isolator and then go into the guarded microprocessor on the guard crossing PCA. So that tells you that all of the stuff inside here is going to be safe, or going to be guarded to minimize stray voltages. And you can see that's from the analog perspective as well. We have all our digital circuits out here in the unguarded space. We have all of that feeding, and then we feed that in through to the analog circuit. So that analog circuit gives the calibrated output, and the power supply fits between the guarded and unguarded circuits. And so that's how they've got this thing to have such great specifications. So let's just pull a couple of these boards and just take a little look at them. One of them that I think is really interesting is the output PCA. So let's pull that up here, and what you see on the output PCA is a fairly standard vertically routed board with a bunch of these cradle relays on them. And now this was part of the reason that I bought this board, was that it had these cradle relays. Let me zoom back out again so that we can take a bit of a bigger look. It had these cradle relays in it that I could utilize to go in and replace any of the relays in my other device. And so this board here is basically the board that will give you, that selects the final outputs and drives those out to the actual connections on the front of the panel. So let me drop this back in here. So let's take a look at another board here, and let's have a look at this guy here. This is the preamp. This is the DAC assembly here, and so on this board here, what we have is an ovenized DAC, and this guy, you can see, is basically going to be running inside this sealed area here, so that it's going to maintain a constant temperature. And what you can see is on the board, as you can see where some of the power regulators have been running a bit hot and they've darkened the board. But basically, we have a bunch of these little protected areas. Oh, let me slide this back in. We have a bunch of these little, ovenized areas on some of these boards that help keep a constant set of temperature, and so the temperatures don't drift. So this guy here is going to be the, which one is it? Let me look up there. This is going to be the differential preamp board. And again, we've got a little ovenized control or shielded control area there with a bunch of these cradle relays. Okay, sorry about the interruption. You can see here one of the areas where they've taken off the solder mask, and I believe they do that because removing the solder mask has shown to help the traces withstand high voltage and high voltage leakage. Ideally, you see it a lot in modern equipment where they'll actually have a slot around the component, and the slot helps, but ideally a bare board plus a slot would give you even more leakage protection. So clearly what they've wanted to do is on these traces that we have on the board here, they wanted to keep that safe from high voltage leakage. These ovenized little containers here that are done, I believe, run at around 50 volts, around 50 degrees Celsius, and kept at a constant temperature. So that's a quick look inside the device here. We didn't go through all of the boards. They use a bunch of these cradle relays. They have a bunch of ovenized components here. That's going to be very different from what you have in the 5440B/AF, the Air Force version. But overall, I think it looks in reasonably good condition. I wonder if it's a similar problem with the front panel to that. I've ordered a new fuse holder, so once I get that, then we'll be able to check out the fuse started up and see if the same lights occur. It'd be awesome if it was exactly the same problem, because it's a 10 microfarad capacitor, I think, and that was the total cost, $65. All right. Well, I hope you found this interesting. I hope you're looking forward to seeing the repair video once we work out what that is. Catch you later. Bye.